CMODE is a tool capable of automatically generate simulation models using as an input an event log. The tool combines process discovery, trace alignment, and replay techniques to extract the simulation parameters. In this demonstration, we will execute two typical scenarios. In the first one, the user wants to explore manually the different preprocessing options of the tool to generate a simulation model. In the second one, the user defines a search space and the tool automatically explores the combination looking for the optimal one. CMO was developed in Python 3.6 and offers a user interface for Jupyter notebooks. To execute the scenarios, as a first step under the General tab, the event log must be selected, followed by the execution mode. For the first scenario, the single execution is required. Then, the user is asked to define the preprocessing parameters. The first one is the percentile for frequency threshold and acts as a filter over the incoming and outgoing edges. The second one is the parallelism threshold and determines the quantity of concurrent relations between events to be captured. These values are required by the split miner algorithm to discover process models with different levels of sensitivity. To deal with the non-conformances between the event log and the BPM discovery model, it is necessary to define a strategy. One option is the removal of the non-conformant traces, being the more natural one. Other option is the replacement of the non-conformant traces using the conformant most similar ones. The last option is the reparison at event level by the creation or deletion of an event when it is necessary. The last parameter is the number of simulation runs. The goal of defining this value is to improve the accuracy of the assessment. Once all the parameters are settled, it is time to start with the execution and wait for the results. Immediately, all the discovery steps are executed. In the console output can be observed how the pre- and processing steps analyze the event log. Finally, the simulation model is executed by BIM Simulator, and all the event logs generated in the simulation runs are compared against the original one. The similarity value is a modified version of the Timmer-Olivenstein algorithm, a well-known algorithm of edit distance. The modification performed is a time penalization between similar tasks based in the mean absolute error. For the second scenario, we will use a different event log, and in the execution mode option, Optimizer will be selected. In the next menu, instead of select a specific value for the mining parameters, it is required to define a range of values. It is not required to define the strategy for the non-conformant management. Instead, it's necessary to define a number of evaluations to perform. With these values, CMODE defines a search space to be explored using a Bayesian hyperparameter optimizer. Once the range of parameters were defined, it is just necessary to click on Start. Immediately, the tool starts to execute the task. In the console output can be observed the steps execution, while in the bottom area the results are presented. In this area, a 3D plot shows the similarity results of each combination between parallelism threshold, frequency threshold, and non-conformance management strategy. Additionally, a table summarizes the result, and this table is updated each time an evaluation is performed. That's all we have for today. Remember, if you have any questions, don't forget to check the links below.